there's something I've been wondering about.
What is it?
The other day, I watched a video about the Dead Sea on YouTube. In the Dead Sea, where there is a lot of salt dissolved in the water, your body naturally floats, and it's even said to be difficult to sink. On the other hand, in a normal bathtub, your body doesn't float, right? I think the difference lies in whether or not salt is dissolved, but I'm curious why that makes your body float.
I see. That's an interesting question. Well then, today let's focus on explaining buoyancy and also connect it to the Dead Sea.
Thank you. I'm excited to learn.
The discovery of buoyancy happened over 2,000 years ago, around 200 BC. There was a person named Archimedes. He was highly knowledgeable in science, mathematics, and also had the skills of an engineer and inventor.
I think I've heard that name before.
Yes, he's quite famous. Archimedes had various achievements. One of them was the discovery of buoyancy. Now let me tell you the story behind it.
Okay.
There was a certain king who gave a craftsman pure gold to make a crown. The crown was indeed completed, but there arose suspicion that the craftsman had stolen some of the gold and mixed in another metal. So, the king ordered Archimedes to come up with a method to determine whether the crown was made of pure gold or not.
Isn't that difficult?
Yes, Archimedes struggled with it. They didn't have the detailed analysis we have today, you see. However, one day while taking a bath, Archimedes realized something. If you place an object in a full container and measure the amount of water that overflows, you can determine the volume of the object.
Wait a minute. How does knowing the volume of an object help determine if a crown is made of pure gold?
Well, as a premise, substances with different densities, but the same weight will have different volumes. For example, 1 kg of water would only take up about half to 1/20th of the space that 1 kg of gold would.
Wow, there's such a big difference.
Yes, that's right. Gold is a substance with a considerably high density, so if other metals are mixed in, the density would be lower than that of pure gold. In other words, a difference in density would occur. Therefore, if we prepare pure gold with the same weight as the crown and find that the sizes are different, we can conclude that the crown is not made of pure gold.
Archimedes realized that he could confirm it by using the water overflowing from the container, right?
Exactly. As a result of the experiment, it was found that silver was indeed mixed in the crown, and the craftsman was said to have been punished.
That's unfortunate, but it's his own fault for stealing gold.
By the way, it is said that at the same time as the current episode, Archimedes also discovered buoyancy. In the first place, the story of the crown and Archimedes' principle are similar. But well, don't worry too much about it.
What is this Archimedes principle?
It's the law that states when an object displaces a fluid, it experiences an upward force equal to the weight of the fluid displaced. Fluid is a general term for liquids and gases, so you can think of it as water or air in this case.
I don't really understand even if you say that.
I borrowed a GIF image from Wikipedia because it was mixed with another metal, silver. The crown has a lower density than pure gold, as I mentioned earlier, and as we saw with the example of water and gold. If they have the same weight, the one with lower density has a larger volume.
So that means the crown has a larger volume than pure gold.
That's right. That's why I want you to remember Archimedes' principle. When an object displaces a fluid, it experiences an upward force equal to the weight of the fluid displaced. Based on this, it can be assumed that displacing a larger amount of water will result in a stronger buoyant force.
So if buoyancy comes into play, then things appear lighter in water, right?
Yes, that's correct.
So since the crown has a larger volume, it experiences a greater buoyant force than pure gold. That's why the balance that was stable in the air becomes unbalanced in water. From this experiment, we can understand that the crown is not made of pure gold.
Yes, that's the meaning of this GIF image. Now, let's further discuss using Archimedes' principle. It's sudden, but you know the saying wood floats on water, right?
Yeah, that's right.
How do you know that?
Well, I've never really thought about it.
Well then, let me explain. When you put a piece of wood in water, it displaces an amount of water equal to its size, creating buoyancy. The key here is the difference in density. If two objects have the same volume, the one with the lower density will be lighter. For example, 1 liter of water weighs 1 kg while gold weighs 20 kg.
Gold is so heavy, isn't it?
Yes, it is. Let me take out the same amount of water as the size of the wood here. Depending on the type, wood generally has a lower density than water, so it becomes lighter than water. So the rule is that the wood receives buoyancy of the same size as the weight of the water displaced by the wood, right?
Because the buoyancy acting on the wood is greater than its own weight. It floats.
You are right.
Oh, by any chance, can we explain why our bodies float in the Dead Sea in the same way?
Yes, that's correct. The water of the Dead Sea contains a lot of dissolved salt. Because of this, while the density of regular water is about 1. On the other hand, the average density of the human body is around 1. Since the density of a human is less than the water of the Dead Sea, we can easily float.
Oh, I see. I vaguely thought that buoyancy was related to floating, but it's good to hear a detailed explanation.
Well then, let's summarize. Archimedes' principle states that when an object displaces a fluid, it experiences a buoyant force equal to the weight of the fluid. Now, let's have a simple test.
Huh? A test?
Imagine if someone jumps into a liquid-like concrete that hasn't solidified yet.
Wow, that's a strange question. Well, I think the density of concrete is at least greater than that of water. And I remember you saying earlier that the density of a human is around 1. So, because the density of a human is smaller, wouldn't they float in the concrete?
Excellent, that's correct. As you can see, even in impossible situations, with knowledge, you can imagine reasonable outcomes. Remember at least the method to determine whether something floats or sinks. Well, that wraps up today's discussion.
I would be happy if you could watch the previous videos and the next one.
Well then, everyone, thank you for watching up until now.
Thank you very much.